Welcome to this presentation for the ice tower that was built in Harbin by the Eindhoven University of Technology in cooperation with several students. Here you will see the final result we realized, but first I will show you some other projects. This is the content of our presentation. So first some previous projects and previous research, and then we'll show how we constructed the structure and how we realized it. This was the first large ice structure we realized with a diameter of 30 meters, and it was realized in Finland. We did two tests, one on flexural strength and one on the compressive strength. Actually, the values are a little bit high because the testing speed was too high. So now we use a lower testing speed, which also give lower results. But this was the first test we did, so therefore we didn't have experience with this kind of material. But what you see is that if you add fibers to it, the strength will become 3 times stronger, as well in compressive strength as in flexural strength. This was the inflatable mold we realized in Finland with a span of 30 meters covered by a rope net. And the rope net pushed the inflatable down to the bottom, and the rope net was anchored to the soil. This is the spraying of the inflatable. So first we added a foundation of snow and ice, and then we start spraying with pykrete. Pykrete is a material of water with fibers of wood, and it was sprayed on the inflatable, and therefore it becomes more ductile and stronger than usual ice. This was the final result we realized. It's a 30-meter span from the inside after removing the inflatable mold. Everybody was really happy with this result. A year later, we came back to Finland to realize a kind of church of ice with 4 domes as an entrance and a very large dome at the back. Here you see the spraying of the inflatables. Because of the weather conditions, we couldn't realize the largest dome, but at the end, everybody was very happy with the result. Here you see the final picture. So in between the domes, we had a kind of rope net, also with ice pins, which looks very nice. Because of the weather conditions in Finland, we went to China with a more stable climate. And inspired by this dress, we made this flamingo ice tower. First, we made a small model, and a year later, we realized that the highest ice tower in Harbin, China. Here you see the inflatable mold with a height of 30.5 meters. And this is the final result just before we took away the inflatable mold. Here you see some workers spraying the tower. After removing the inflatable, this is the result from the inside. And here you see another picture from the inside with a shell with just a thickness of about 7 centimeters at the top. So you can see the light coming through the ice. This is the final result with the opening. And this is me just after the opening in front of the ice tower. So a year later, we wanted to do something else. So we did some research in extruding of ice. And with this method, we realized this grid shell made with ice on an inflatable mold. And this is our team realizing this grid shell. We also tested the grid shell and at the end it could stand about 6,000 kilograms. So now we'll focus on the latest project we realized in Harbin, and before this we did some testing into the strength of ice. So this was the first design we made, and later we did some structural analysis for this design. The structural analysis was done in the program Grasshopper with the plugin Kangaroo. And we looked at stiffness, element length, and so on. For the calculation, we used the material properties, as you can see in this slide. And we used the values as a maximum compressive strength of 1 MPa and a maximum tensile strength of 0.3 MPa. The structural analysis was then with the program SIA. From the material research we did, we found that the flexural strength for the rope elements were 4.4 and for the hose 1.8. Our conclusion is that the structure works and is really safe. Of course, it's a bit overdimensioned, but that's usual in this case because you want to have it as safe as possible. Okay, thank you for listening. If you have any questions, I will be happy to answer.